Coordinate geometry. So in coordinate geometry, we're going to look at equations of a line, gradient, coordinates of the midpoint of a line, point of intersection of lines, and also equation of a circle. Okay, so let's begin. Suppose we have a straight line graph like this one. I'll just control here. Just a simple straight line graph, x-axis and our y-axis. Right. Okay, so we have a straight line graph like this one, and we're going to say this is our x1, and this point here is our x2, this one is our y2, and our y1 we're going to say is this one. Right, and this is where the graph intersects at y. We're going to say that's C. So where our x1 and x and y1 meet, we're going to say our coordinates are x1 and y1, and same the coordinates for this side, will be x2 and y2. So we're going to start with the equation of a line. So equation of a line is y is equal to mx plus c, where our m is the gradient of the line, our c is the y-intercept, so how do we find the gradient of that line? So gradient is it's just easy. So our gradient m is equal to change in y over change in x. In other words, our gradient is y2 minus y1 over x2 minus x1. So our y2 being the coordinate there, and our y1 being this coordinate, same with the x-axis. So I'll do just a simple example. So here's a question. Find the equation of the line through the coordinates minus 1, 2 and 3, 0. So we're asked to find the equation of a line that passes through those two coordinates. So we know that the equation of a line is y is equal to mx plus c. So first we're going to find the gradient of the line. So our gradient m is equal to y2 minus y1 over x2 minus x1. Okay, so we're going to say this is our y2 and this is our x2, this is our x1 and our y1. So our y2 is 0 minus y1 2 over x2 is 3 minus x1 is minus 1. Okay, so for our gradient we're going to get -2/4. So if we simplify that, it's equal to -1/2. That's our gradient m. So after we find our gradient, we substitute in order to get the y-intercept c. So here's our equation: y is equal to mx plus c. So our y, we pick any coordinates here. So I'm going to pick 0. 0 is equal to our m is -1/2, and our x here is 3 plus c. So if we simplify that, you get 0 is equal to -3/2 plus c, and so our c is equal to 3/2. Right, that's our y-intercept. So the equation for this line is y is equal to, our gradient is -1/2 x plus 3/2. Simple as that. Okay, so there are other ways to find the equation of a line. So alternatively, we could use this method. M is equal to y minus b over x minus a, our m being the gradient, of course. So in this case, our a and b, these are any points on the line. Any points on the line, right? So how do we solve this one? It's easy. We clear fractions first. So m times x minus a should be equal to y minus b, right? So let's simplify. Okay, so if we simplify that, it's going to be y minus b is equal to m times x minus a. So we pick any points on the line. I'm going to pick -1 and 2, right? So y minus b is 2 is equal to m, x is -1, m x minus -1, right? So y minus 2 should be equal to -1/2 x plus 1, because we already have the gradient. So y minus 2 equal to -1/2 x minus 1/2. So if we simplify this, our y will be equal to -1/2 x minus 1/2 plus 2. So that simplifies to y is equal to -12 x plus 3/2. As simple as that. So sometimes the question may require you to express the equation of the line in the form ax plus by plus c is equal to 0. So this is easy. What we do, we just clear fractions. So for our equation, y is equal to negative 1 over 2x plus 3 over 2, we just multiply everything by 2. So 2, 2, so it becomes 2y is equal to minus x plus 3, and then move everything to one side. X plus 2y minus 3 equals 0, just like that. So what if lines are parallel? If lines are parallel, their gradients are equal. For example, if line L is let me write this one. So for example, so we said if lines are parallel, their gradients are equal. So for example, if line L is parallel to the line with equation 2x plus 6y is equal to 15, and passes through the coordinates minus 3, 2, find the equation of L. Alright, so we said if lines are parallel, then their gradients are equal. So which means if line L is parallel to the line that has this equation, it means their gradients are equal. So here, this equation, if you first need to make y the subject in order to find the gradient. You make y the subject in this equation. So it's simple. It should look like is 6y equal to minus 2x plus 15. So we divide everything by 6. We remember y is equal to minus 1 over 3x plus 5 over 2. Right. So we know that the equation of a line is y is equal to mx plus c. So now we know that this is the gradient. So our gradient m for that line is negative 1 over 3. So since line L is parallel to the line with that equation, it also means that the gradient for line L is 1 over 3. So to find the equation of line L, we already have the gradient and the coordinates of the x and y axis, which is simple now. Y is equal to mx plus c. So our y is 2, negative 1 over 3 times our x is negative 3 plus c. So 2, 1 plus c. So our c is equal to 1. So the equation of line L is y is equal to negative 1 over 3 x plus 1. As simple as that. So what about perpendicular lines? If lines are normal to each other? Well, if lines are perpendicular, or in other words normal to each other, the product of their gradients is minus 1. So I'll show you how it's done. So as I was saying, if two lines are perpendicular to each other, the product of their gradient is -1. So for example, if we had line L1 and the gradient was m, and our line L2, its gradient was n. So if these lines are perpendicular, we would expect that the product of their gradients, m times n, should be equal to -1. So in other words, the gradient of of line L1 should be equal to -1 over the gradient of L2. So let me do it with an example. So let's say our line L1, the gradient was 3/2. This means that for our line L2, the gradient is -2/3. So here's an example. It says the line y is equal to -2x minus 6 is normal to line P passing through the coordinates 0 and -2, and we're asked to find the equation of line P. So the line which is normal or perpendicular to line P is this equation. Y is equal to -2x minus 6. So the gradient for this line, we know that the gradient is -2. So what about the gradient for line P? So the gradient for line P in this case would be -1/-2, like that. So that simplifies to 1/2. That's the gradient for our line P. So the equation for line P, y is equal to mx plus c, and we have the coordinates for our x and y coordinates are 0 and 2. So we substitute -2, our gradient is half, x is 0 plus c, so that becomes 0. So our c is equal to -2. So the equation of that line is y is equal to 1/2 x minus 2. Simple as that. And so we move on to the coordinates of midpoint. So coordinates of midpoint of a line. So let me draw a line, just a simple line as an example here, and say this is our line AB, and the midpoint, say that's our midpoint is M. Say our point A has these coordinates x1 and y1, and our point B has the coordinates x2 and y2. So to find the coordinates of M, in this case, we say half x1 plus x2, then half y1 plus y2. So the answer here will be the x coordinate, and the answer to that will be the y coordinate. So for example, let's take for example and say we have a line like this one, and this is the midpoint P. Say our midpoint is P and our line x, y. Say for the coordinates for point x are -1 and 5, then coordinates for y are 7 and -1. So the coordinates of P in this case, we say half x1 plus x2 and half y1 plus y2, which is -1. So that simplifies to the x coordinate is going to be 3 and our y coordinate 2. So that's how you find the coordinates of the midpoint of a line. So what about the point of intersection of two lines? The point of intersection. Well, let me draw two lines here to illustrate that. Suppose that is point of intersection x, and this line is the equation y is equal to mx plus c, and this one is the equation ax plus by is equal to c. Okay, so the coordinates are the solution to the simultaneous equations. Right. So if you solve the simultaneous equation ax plus by is equal to c and y is equal to mx plus c, you will get the coordinates of the point of intersection. So let's do an example. Let me write down the question. Alright, so there is a question. It says line L has equation 3y plus 2x is equal to 8, and point A has coordinates 1, 15. Show that line A perpendicular to L has equation 2y minus 3x is equal to 27, and hence the perpendicular distance of A from L. Alright, so first we have the equation of line L, which is 3y plus 2x is equal to 8. So first let's find the gradient. We make y the subject, so 3y is equal to minus 2x plus 8, and so our y is equal to minus 2 over 3x plus 8 over 3. So gradient of line L is equal to -2 over 3, and in our question it said A is perpendicular to line L, so that means the gradient of our line A should be equal to 3 over 2. The product of the gradients of perpendicular lines should be -1. So if you multiply that, you're going to get -1. So now we have the gradient of line A. So now we find the equation. So the equation of a line is y is equal to mx plus c. So we have coordinates for A, which are 1 and 15 is 15 here. That's the coordinates. So our y is 15 is equal to 3 over 2 times 1 plus c. So our c is equal to 27 over 2. So we should express the equation of this line in the form ax plus by plus c is equal to 0. So originally our our y is equal to, the gradient for a is 3 over 2 x plus 27 over 2. So we multiply everything by 2 to clear fractions. We're going to get 2y is equal to 3x plus 27. Then move everything to one side. We get 2y minus 3x minus 27 is equal to 0. Oh, by the way, it said we should leave it in the form 2y minus 3x is equal to 27. So there, we've proven it. And hence, the question said, and hence find the perpendicular distance of A from L. So, how do you find distance? So let me draw a simple sketch here to illustrate how we can find distance between 2 points in a line. Okay. So here, suppose this is our point A and this is our point B. And the coordinates for A are x1 and y1. And the coordinates for B are x2 and y2. So to find the distance between these two, we're going to use Pythagoras theorem. Yes. So from Pythagoras theorem, we know that AB squared is equal to x1 minus x2 minus x1 squared plus y2 minus y1 squared. So the distance between those two, AB, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So to find the distance of from our line A to our line L, we use the same method. So let me just illustrate this here. And say that's our line A and this is our line L. Line A is this points 1 and 15, and this is the point of their intersection of line L and line A. We have the equation for line A and the equation for line L, so we're going to make them simultaneous equations in order to find their point of intersection. We're going to solve them simultaneously. So multiply this one times 2 and then this one times 3. It should give us 6y minus 9x is equal to 81, and 6y plus 4x is equal to 16. When we subtract, this should give us 13x is equal to 65 minus 13x, and over 13, our x is equal to negative 5. Divide by negative 13. So this is our x coordinate, and our y coordinate we use, just pick one equation. I'm going to pick 3y plus 2. Our x is negative 5 is equal to 8. So 3y minus 10 is equal to 8. 3y is equal to 8 plus 10. 3y is equal to 18. Then our y is equal to 6. So their points of intersection x there has the coordinates minus 5 and 6. So to find the distance, distance between those two lines is equal to the square root of 1 minus 5 squared plus 15 minus 6 squared. So I used the coordinates of line A and the coordinates of the point of intersection. This should give us the square root of 36 plus 81. So their distance is equal to root 117.